Given that f of x is equal to x squared minus 6x plus 18, and x is greater than or equal to 0, I need to express f of x in the form x minus a all squared plus b, where a and b are integers. So this is completed the square form. So I need to complete the square on f of x. So I am going to half the 6, which is 3. I'm then going to take away 3 squared, and then I'm going to add the 18 on the end. So that gives me x minus 3 all squared. The minus 9 plus 18 is plus 9. So that's my f of x function. So a is the 3 and the b is the 9. The curve C with the equation y equals f of x, where x is greater than or equal to 0, meets the y-axis at point P and has a minimum point at point Q. I need to sketch the graph showing the coordinates of P and Q. So let me draw a set of axes here. Here's my x-axis. Here's my y-axis. Right, so I can see that it is going to intercept on the y-axis when x equals 0. So these terms here will be 0, and the y will be equal to 18. So I'm going to mark on the point 0, 18 here. The completed the square form, this allows me to say that the minimum point is the point 3, 9. 3 because of the x minus 3 on the inside of the brackets, and the 9 because of the plus 9 on the end. So this is the minimum, 3, 9. And so my curve looks like this. That's my quadratic, except I'm going to adjust that slightly because I was told that x is greater than or equal to 0. So actually I don't need to include the bit where x is less than 0. And I'm also going to label up P and Q. I was told that it meets the y-axis at point P. So this is point P, where the coordinate is 0, 18, and the minimum is point Q down there. Right, we are then told that the line y equals 41 meets the curve at the point R. We need to find the x-coordinate of R, giving our answer in the form P plus Q root 2, where P and Q are integers. Right, I'm just going to take I want to try and mark on what this looks like onto my graph. So let me just create a bit more space, because I need to go all the way up to 41 here. It's just a sketch, so it's not going to be perfectly accurate. But... So my curve's going to look like that. 41 is roughly here. So here's the line y equals 41. And we can see it's going to intersect the curve in one place here. So I can do simultaneous equations because we're talking about where the lines intersect. So where my quadratic, where that equals 41. So to solve this, I'm going to rewrite my quadratic in its completed the square form, because I think that's going to be a little bit easier for me to solve. So all I've done there is I've rewritten this in the quadratic completed the square form, because we know f of x can be written like that. Take the 9 off both sides, square root. So when I square root, I know I'll get plus or minus root 32. And the root 32, well, that's the same thing as 4 root 2, because root 32 is the same thing as root 16 times 2. And the square root of 16 is 4. So I could replace that root 32 with 4 root 2. Finally, I'm going to add 3 to both sides. So I find that x is either 3 plus 4 root 2 or 4 minus root 2. I then just need to think about which of those it's going to be. Well, it's going to be the 3 plus 4 root 2 because the x coordinate here is positive. That is where x is 3 plus 4 root 2. The minus answer, the 3 minus 4 root 2, would be if my graph continued into the negative part of the axes, and then I would find out that the x coordinate here would be 3 minus 4 root 2. But we're not interested in that because we were told that x had to be greater than or equal to 0. So my answer is 3 plus 4 root 2. And you can see that is in the required form.